it's important to know your units, okay, and know what units are on the top and on the bottom. So looking at this problem here, we're going to convert 2.34 grams, so 2.34 grams of aluminum to the number of moles of aluminum. So what we want to do is go to our periodic table and find aluminum. So here is aluminum here. And so when we look at aluminum, we look at its atomic mass, and it is 26.982. So we're going to convert that to 26.982 grams for 1 mole. So that's going to be our conversion factor. So if we take a look at our problem here, I start with my 2.34 grams, and I'm going to use the conversion factor of my multiplier of 26.982. Now to determine which way it goes, we just determined that I need to have the grams cancel out. So this is why keeping track of units is important. I need to make sure the grams in that ratio are on the denominator. This way now the grams will cancel out. So I can see that these grams units cancel out, and then I'm left with moles. So I take 2.34 times on top, divide on bottom, I divide it by 26.982. And for my calculator, that's going to give me 0.087, and the units are going to be moles because that's the number of units that are left. So that number of grams of aluminum represents 0.087 moles of aluminum, and I can convert that to atoms of aluminum by multiplying that by Avogadro's number. So example 2 here says we have the number of atoms here. So I have 1.3 times 10 to the 19 atoms. So that's a lot of atoms of carbon. And we want to convert that to the number of grams of carbon. Okay, so we're going to first start off with our atoms. And we want to convert this into moles because most of our units are going to be in molar units. So the first thing I do is I take my conversion factor of 1 mole equals, 1 mole equals 6.023 times 10 to the 3 atoms. So that ratio then I'm going to use, and then to determine which of those goes on bottom, I see that I have atoms here. I need to cancel with atoms on the bottom, so that means I need to divide by the 6.023 times 10 to the 23 atoms. So those units now cancel out, so I'm left with moles. Once I have my moles, I can use my molar conversion. So I go again back to my periodic table, look at carbon, and I look at the atomic mass. Atomic mass is 12.011. So that means that we're going to use 12.011 grams per mole. And since I need to cancel the moles out, that's how many grams for 1 mole. So then I have 1 mole on top, 1 mole on bottom, those cancel out. So at this point I do my unit analysis or my dimensional analysis, and I can see that the atoms cancel out. I'm left with grams, that's what I want. So I take all the times on top, so 1.3 times 10 to the 19 times 12.00011, and I'm going to divide it by Avogadro's constant, and I end up with my units are grams, and the number is going to be 2.592 times 10 to the negative 4, so very few grams, a really small amount. That many atoms results in a very small amount of grams.